Okay, in this video, I want to discuss finding the center and radius of a circle given a certain form, okay? Now, you remember from the previous video that we had two different forms for a circle. We had what we called the center radius form, okay? And that was x minus h squared plus y minus k squared equals r squared, where the center was hk and the radius was r, little r. Okay, and then we had a second form called expanded form, or that I called expanded form. X squared plus y squared plus ax plus by plus c equals 0. Okay, where a, b, and c are constants. In fact, they're real constants. And I do want to throw this in this time. For the equations here, x and y are restricted to real numbers only, not complex numbers. Okay, real numbers that are not, real numbers with zero imaginary part. Okay, well, let's take an example here. Now, looking at these two forms, you can probably already tell here that the center radius form, if a circle's in center radius form, it's going to be a lot easier to figure out what the center and radius are because they're virtually sitting there for you. Trying to find the center and radius of a circle in expanded form is going to be rather more difficult here. Okay, let's take the easy case first, though. Example 1, find the center and radius of x minus 2 squared plus y plus 5 squared equals 100. Okay, so you can see that that's a circle, and it is written in center radius form here. Okay, here's our center radius form, just for emphasis. X minus h squared plus y minus k squared is equal to r squared. And then we just associate corresponding parts, essentially. So the x minus 2 would correspond to x minus h. Knocking off x on each side here and solving for h, you can see that h is going to be 2. Likewise, y plus 5 would correspond to y minus 10. Knocking off the y's on each side and solving for k, we can see k would have to be negative 5. And the last thing, be careful here. Remember, this number isn't r, it is r squared. So we've got r squared is 100. That means r is the square root of 100, or 10. So what we can say is that the center is at 2, negative 5, and the radius is 10. Okay, I got a little sloppy there. Okay, but that's supposed to be 10. Okay, so like I say here, going from the center radius form, it is easy to find the center and radius, okay? How about finding the center and radius of a circle if it is in an expanded form? Okay, we chatted about that a minute ago. That's going to be a little bit more work, but let's go ahead and show that it is doable. Let's talk about example 2 here. Find the center and radius of this circle. X squared plus y squared plus 2x minus 6y minus 6 is equal to 0, okay? That's a circle. You could graph it in Desmos, and you could figure out what the center and radius of that circle are from looking at that. Okay, here's what I'm going to do, though. We're going to use completing the square on both the x terms and the y terms, okay? This is going to be kind of like what we did when we were solving quadratic equations doing it. Okay, we see we've got the constant term negative 6 over on the left-hand side. So the first thing I'm going to do here is add 6 on both sides. Okay, so all I have is what? X terms and y terms over on the left-hand side and a constant term over on the right-hand side of the equality. And here's where I say complete the square on both the x and y quadratic polynomials. So for convenience, what I did here was gather the x terms together. So I've really got x squared plus 2x, and I use parentheses there. Okay, then I've got y squared minus 6y, and then the 6 on the other side. Okay, now complete the square on each of those polynomials. Those are quadratic polynomials, right? Complete the square on each of those. Notice that they're monic, right? The leading coefficient on each of those polynomials is 1. It's 1x squared, and it's 1y squared. Okay, so we can use our little trick, right, of adding a certain magic number to that quadratic polynomial to make it a perfect square. Okay, What was the trick? You take half the coefficient of x, so that's 2 divided by 2, and then square that result. You get 1, okay, in this case. So you see I came down here, I added 1 in here, okay, and negative 6 over on the y polynomial divided by 2 squared is 9, so I added 9 to this fellow. Now remember, if you expect this to still be a valid equal sign, right, if I add 1 to this side and 1, then I better add 1 to the other side to keep it balanced, right? And then I also did what? I added 9 to this side, right, with the y polynomial, so I better add the 9 to the other side too. So that 1 and the 9, I better add those over on the right-hand side also, okay? A common error for students to make is to just forget about writing or adding those constants on the right-hand side. Make sure you don't do that, okay? All right, now if you played your cards right here, these two quadratic polynomials should be perfect squares, and you just have to think about what they would be the perfect squares of. If you just contemplate for that for a moment, you'll see that the first polynomial is actually x plus 1 squared. The second polynomial is actually y minus 3 squared. The constant we get on this side turns out to be 16. So you see what I've done through this completing the square process. I've actually taken the expanded form and converted it into what? Center radius form. And now that's in center radius form, it's fairly easy to deal with, like in example 1. Okay, so again, we're comparing with x minus h squared plus y minus k squared equals r squared, so that we would have, let's just be a little quicker this time, we see the h would have to be negative 1 to get x plus 1, okay? The k would have to be 3, since it's y minus k, so y minus 3, so k is 3. So I've written the center negative 1 comma 3. And then r, remember this represents r squared, not r. So I took the square root of 16 and got 4. Okay, so the radius is 4. And then I'm done. I boxed in my final answer. Okay. All right, let's do another one, the one that just kind of messed up here. This isn't intrinsically any harder. You just have to do a little bit of rewriting first. Find the center and radius of this. X squared plus 10y equals negative y squared plus 8x. Believe it or not, if you were to graph that on Desmos, that would give you, writing it just like that, that would give you a circle, okay? So I just wrote that. It's kind of a messed up expanded form, isn't it? Okay, that's no technical term. Okay, what I'm going to do is go ahead and subtract 8x on each side, okay? Okay, and I'm going to put those x terms together because you know I'm going to be completing the square here. And then I added the y squared on each side. I gathered those y terms together, again for completing the square. And that left me with the constant on this other side being simply 0. Okay, now let's go ahead and perform our magic trick here. These are monic quadratic polynomials. So I need to just take half of negative 8 and square it. That gives me 16. If I do it on one side, I better do it to the other side. So I got 16 on this side. Okay, half of 10 is 5. Squared is 25. So I add 25 to each side. Okay, strategically here. So on the left-hand side, I should have perfect squares now. I've got x minus 4 quantity squared, as a matter of fact. And we have y plus 5 quantity squared for the y polynomial. And then 16 and 25 actually adds to what? 41, okay? So let's do an irrational one this time. Now, x minus h plus y minus k squared equals r squared. Okay, so you can see that the h would have to be positive 4, and the k would have to be minus 5. So the center is 4, negative 5. The radius would have to be the square root of 41, since the 41 is the square of the radius. Okay, so this is somewhere between 6 and 7. You could use your calculator to get an approximation. Okay, I hope you understood those. That should help you with some of the homework problems that I've given you.